Hi guys, this video is the second video on Redox and it goes through some further past paper questions. This first question, we've got tungsten oxide reacting with hydrogen to produce tungsten and water, and using our oxidation number rules we have to assign oxidation numbers to find out what's been oxidized and what's been reduced. So the tungsten, W is its element symbol, has gone from +6 to 0, and the hydrogen has gone from 0 because it's an element in its standard state to +1. And I've not taken into account the balancing numbers and the oxidation states we assign, that's for each atom of each element. So we've got 2 hydrogens in H2O, but each hydrogen there is +1. Because oxygen's -2, we've got 2 hydrogens that must be +2 to make it add to 0, so each hydrogen is +1. So what's been oxidised? It's a thing that's increased its oxidation number, that's hydrogen, and we say what it's gone from and to. And tungsten, the W, has gained electrons, it's been reduced, it's gone from +6 here to 0 when it's an element in its standard state. The next question is about chlorine, and it's asking us for the systematic name, so the proper chemical name for this compound. We've got sodium, so the name's going to start with sodium. We've got chlorine, so it's going to be chlor. 8 means many oxygens in chemistry, whereas ide means no or few oxygens. Now we should also add to our answer a Roman numeral which gives the oxidation number of the chlorine, and I've worked those out here. So sodium is a group 1 metal, its oxidation number is +1. The oxygens, each oxygen is -2. We've got 3 of them, so overall oxygen is -6. It's a neutral compound. That means these oxidation numbers, the pluses and minuses, have to add to 0. Therefore chlorine must be +5. Next part of this question is about disproportionation, and this is something special that group 7 elements can do, and it's when they're both oxidized and reduced in the same reaction, and that happens when we've got 1 lot of the group 7 element on the left hand side and 2 lots of it in 2 different compounds on the right. So to get 3 marks, I've defined disproportionation. It's when the same element is both oxidized and reduced in the same reaction. And I've assigned oxidation numbers to each element in this reaction to find out what is happening to the chlorine. And I've said it's oxidized when it goes from +5 to +7 in sodium chlorate, and it's reduced when it goes from +5 to -1 in the sodium chloride. Now this last question is probably the most trickiest one on these examples. We've got a table and it gives us names of ions. The Roman numeral tells us the oxidation number of the nitrogen, the sulfur and the chlorine. It gives us the ionic charge. This is the charge on the overall ion, and that means the sum of the oxidation numbers must add to equal that charge overall. So for the nitrate, the nitrogen and oxygen oxidation numbers must add to give -1. For the sulfate, the sulfur and oxygen oxidation numbers must add to give -2. So I've written on the left hand side what I'm doing. Sulfur must be +4, that's what information this Roman numeral gives us. Chlorine in this one must be +3, that's Roman numeral 3. And then it might be trial and error. You might write down some formulas. 8 usually means 3 or 2 or more oxygens. And you have to work out oxidation numbers until it meets this overall charge. So, sulfate 4, if the sulfur's +4 and we want a 2- left over, that means the oxygens must add up to -6. And to get that to happen, there must be 3 of them, because -2 times 3 is -6. The chlorate, we want 1- left over, and the chlorine is +3. That means we must have 2 oxygens, because -2 times 2 is -4. We need 1- left over, and chlorine is +3. And the very last part of this question, write the formula for aluminium nitrate 5, and that's telling us the oxidation number of the nitrogen. So aluminium forms a 3+ ion, it's in group 3. Nitrate, the ion is NO3 1-, so we need 3 of the nitrates to balance out this 3+ charge on the aluminium. That is the formula of aluminium nitrate. Then let's check that the nitrogen has an oxidation state of +5. So in the nitrate ion, we've got 3 oxygens, -2 times 3 gives -6. We want 1- left over, so the nitrogen must be +5. So this is correct.